Welcome to STB 3022 Environmental Biotechnology. We are from Lecture Group 3, Subgroup 3.
I'm Wellheirnie Aren, Anak Minggu 62910.
I'm Tiing Tiing with matrix number 62736.
Hi, I'm Zaireen Zuleeka. My matrix number is 62985.
Hi, my name is Carentona. My matrix number is 62512.
I am Yeaw Zi Xuan with the matrix number of 62955.
So first up, journal title. Today we are here to present to you guys on a journal that entitled Energy Recovery from Liquid Wastes of a Sewage Treatment Plant.
Let us move into the introduction. Basically, the study emphasized on the importance and benefits of recovering energy from liquid waste treatment. Undeniably, intensive exploitations of fossil has caused a drastically decrement in the natural resources all over the world. Therefore, we should pay more attention on renewable energy sources, especially on the biomass such as wood waste, straw, paper, and the deposit from the sewage treatment plant.
Actually, biomass can be used as direct substitute for fossil fuel, and biomass can be also processed into liquid fuels such as oil and alcohol. Besides, biogas generated at dumping site and during fermentation process of various organic sludge can be also used as an energy source.
In this study, researchers highlighted that the sludge from municipal sewage treatment plant can be the substitute fuels, at which, by utilizing this waste, compost may be produced and processed into valuable fuel, such as briquettes. Wherewith, briquettes have the same weight as brown coal, and combustion of briquette can be even achieved with lower air pollution.
So next, research objective. This research aimed to indoctrinate waste-to-energy process through energy recovery from a liquid waste of the sewage treatment plant, as well as identify and search for the substitute fuel through the technology of composting and briquette production.
So, let's move to the method part. In order to recover energy from liquid waste, the most effective method that can be used to convert the sludge into compost will be the non-oxygen-oxygen method. Actually, the non-oxygen-oxygen method can be divided into three main stages. The first stage is oxygen-free stage of composting. At this stage, the increase in the inner temperature of the waste causes partial pasteurization of deposit and also the reduction in the number of Kurcz bacteria. The second stage is oxygen-1 stage. The air blown through the pile helps to speed up the organic compound decomposition. The third stage is the briquetting process. Briquetting process is the granulation and addition of artificial additives to obtain some kind of fertilizer. The end product is obtaining a substitute fuel with a calorific value of over 10 megajoule per kilogram. The following chart shows the process of composting the sewage sludge in order to produce the organic fertilizer.
Next is the experimental arrangement of the furnace that equipped with apparatus for combustion process, and the apparatus that shows included combustion chamber, exhausted, and chimney. The following table shows the average composition of the briquettes such as carbon, hydrogen, sulfur, oxygen, and so on. So let us move into the result and discussion part.
The graph below shows the concentration of carbon monoxide, nitrogen dioxide, and temperature of fuel gases during briquette combustion.
Based on the graph that shown just now, comparison between the nitrogen oxide and temperature reveals that the main source of the nitrogen oxide is nitrogen content in the nitric compound of the fuel, and this process will not influence the amount of nitrogen dioxide being emitted into the atmosphere.
From the graph shown, we can also conclude the concentration of sulfur dioxide did not exceed a value of 1 to 3 parts per million by volume during combustion of briquette and raw compost, and we assume that the emission of sulfur dioxide was equal to 0. Table below indicates the concentration of heavy metals and carbon present in ash and fly ash after combustion. We can conclude that heavy metal concentration in the compost is relatively low.
So next, table below shows that the emissions of the components such as nitrogen dioxide, carbon monoxide and fly ash into the atmosphere, at which these data are important because they can be used to determine the pollutant propagation in the atmosphere. So let us move into the conclusion part. In conclusion, both the objectives were achieved successfully, wherewith the waste-to-energy process was interconnected and performed successfully, and the substitute fuel were produced successfully through the process of composting and briquetting. So for the final part, reflection. So let us start with the benefits part. So the first benefit that can be deduced from this research is that the briquettes produced from sewage sludge can serve as the substitute fuel because the combustion and thermal condition of the briquettes and brown coal are the same. So next, the second benefit is that briquettes combustion is environmentally friendly because briquettes is burned with zero sulfur dioxide emission due to low sulfur content in the briquettes. Besides, briquettes is also burned safely within the emission restriction due to low concentration of the heavy metal. Furthermore, briquettes combustion is also considered as a clean burning because it causes lower air pollution. Next, the limitation part. So the first limitation is that sludge contains high moisture content, thus the sludge need to be undergo dewatering process before it can be converted into compost. Besides, the second limitation in this research is that the cost of the ash disposal is relatively high. And finally, for the suggestions part. So the first suggestion is that the laboratory scale combustion chamber can be changed into pilot or industrial scale combustion chamber. This is because scaling up the combustion chamber can help the researchers to get a better and consistent result and at the same time to get higher yield. So next, the second suggestion is that the combustion chamber should be changed into the hydroelectric power plant. This is because combustions produce carbon monoxide that can pollute the environment and bring harm to humans.